All right, we've got a big topic tonight, quadratic inequalities in two variables. So I need you to stop and get your calculator and make sure you are practicing along with us. Our last question involves a lot of calculator steps, and I do mean a lot. So again, make sure you have your calculator with us. Real quickly, just some recalling from algebra. This is the less than symbol, and this is the less than or equal to symbol. Okay, if I flip them the other way, I have the greater than or equal to symbol. One thing we're going to do a lot of is graphing lines. So I just want to be clear, when you see the less than symbol, this is a dashed line. When you see the equal to underneath, this tells you a solid line. So again, this one would be dashed greater than. The equal to underneath there would be a solid line. All right, so grab that calculator and let's dive in. Exercise 1. For the quadratic inequality, y is greater than x squared minus 4, answer each of the following questions. A. Specify whether each of the following points lies in the solution set. So remember, they just gave us an x and a y. And I just want to know if it's in the solution set, I'm looking for it to be true. So I'm just going to plug them into my equation. Y is 4 is greater than, remember substitute with parentheses, 1 squared minus 4. So I've got 4 is greater, 1 squared minus 4 is 1, and 1 minus 4 is negative 3. Would you say that's true or false? I would definitely say that is true. 4 is greater than negative 3. We'll do the same for the next one. This time my 0 is my y, is greater than 2 squared minus 4. Is 0 greater than 4 minus 4 is 0? True or false? Well, 0 is actually equal to 0, not greater than 0. So that one I'm going to say false on. And lastly, I have 1 is greater than negative 2 squared. Notice my square is outside. So that's 1 is greater than 4 minus 4 is 0. I would definitely say 1 is greater than 0 is true. B. Do the points on the parabola y equals x squared minus 4 fall in the solution set of the inequality? All right, now let's think about that. Do the points that actually lie on the parabola fall into this inequality? Well, are the points equal to that inequality? That's what I'm looking at. If I see this symbol, does that mean equal to? I want to say no. Remember, this means greater than. Okay, it does not mean equal to. If the symbol looked like this, then my answer would be yes, because that's greater than or equal to, or I guess I should say and equal to. Okay, so since I'm saying the point's right on the parabola and because it's not an equal to, my answer is no. Part C, sketch the inequality below, label the solution set Q. Alright, well basically, all I'm going to do is throw, now that y is by itself, I'm going to throw this in my y equals, type in x squared minus 4, so grab your calculator. After you have that typed in your y equals, I want to show you another little trick on our calculator. I want you to hit zoom, which is on the top row, and the number 6 for standard. This is special because it will always take you to a nice 10 by 10 grid. So let's mark that in our notebook under maybe some calculator tips. Zoom 6 is our standard window. Once I have that, I'm just going to go to my table now and plot points. So hit that table button in the upper right hand corner, we've been there before, and let's plot some points. Now, take note in this, I've plotted my points and I have not connected them yet. Before I connect, I need to look at this symbol, and this will tell me if my line is going to be solid or dashed. Because I'm not equal to, that is implying I am going to have a dashed line. And again, let's mark that in our notebook. I'm not equal to, so I'm going to have a dashed line. So don't connect them with a solid line. We're going to nicely dash our line in because we are not equal to. Now, our last step is to always test some points to determine where we're going to shade. And remember, we're going to shade where it's true. Whoops, I missed my A. Shade where it's true. So that's what part A was leading us into. We said it was true at the point 1, 4. So I'm going to plot the point, or not plot the point, I'm going to go to the point 1, 4, over 1, up 4, and I know I'm going to shade in this section. Notice I'm not going to shade. It was false at 2, 0. So I'm not going to shade there. That's right on the line and it's not equal to. And again, it was true at negative 2, 1, which is inside there. So I just want to be clear, I am shading inside this parabola. And lastly, it said label your solution set Q. I'm just going to stick a big Q in there. All right, so hopefully nothing too tricky today. We're going to use our calculator a lot and we're going to test some points. All right, exercise 2. Sketch the solution set of the system of quadratic inequalities below. Label the solution set A. State one point that lies in the solution set. Now notice they're saying solution set, and that's implying that there are two questions we're going to graph on the same set of axes. So let's just start with the first one. Okay, y is by itself. That's my first check. So go to your calculator, type in 6 minus x squared. Bring up your table, and let's plot some points. So pause it and start typing that in and plotting your own points. Okay, now notice I haven't connected my points. That's where I come back and I look at this sign. All right, and write it on your same paper. Am I equal to or not equal to? Well, I don't have the line underneath, so I'm not equal to, which tells me I need a dashed line. Okay, so we're looking for nice, exact graphs in your notebook there. If you have graph paper, that's even better. Perfect. All right, now remember, I'm not done till I shade, so now I test a point. And it's easy. You just pick any point that's not actually on the parabola. So I like to pick somebody inside. I think the point 0, 0 is the easiest point if it's not on the parabola, so I'm going to start with that. And I just jot down my point 0, 0, and I'll plug this into x and this into y. So I said 0 is less than 6 minus 0 squared. Would you agree or disagree that 6 is less than 0? Hopefully, you say no-brainer. 6, whoops, I'm saying it backwards. 0 is less than 6. So that is definitely true. And remember, you shade where it's true. So 0, 0 is here. I'm going to shade that section in. And again, if you have colors, this is what makes it very handy. I would do my next example in a different color. So remember, this is a system, so I'm putting 2 on one graph. So now we'll take that second equation. Y is greater than x squared minus 4x plus 3. Pause it, go to your calculator, type it in, go to your table, and plot the points. All right, I've got my points plotted. Before I connect them, go back and look at this symbol. Are you equal to or not equal to? Well, remember, that line underneath tells me I'm equal to, so that tells me I want to see a solid line. So as I connect them, make sure you have a solid line. One other note is make sure your graph always extends from paper to edge of the paper to the edge of the paper. Make sure it goes from this edge up to this edge. My green one went from here down to here. And just to imply that this graph goes on, let's make sure we have arrows on the end. Now remember, you're not done till you test a point. You need to pick somebody either inside or outside. I'm going to pick, so I'm looking at my blue section, and I'm going to pick that same point, 0, 0, and see if it's true or false. So 0, 0, you can pick any point you want. Is 0 greater than or equal to 0 squared minus 4 times 0 plus 3? Is 0 greater than or equal to 3? Hopefully you're saying that that is very, very false. 0 is not bigger than 3. That means you cannot shade where 0 was. And notice, compared to my blue, 0 was outside. So that's telling me I need to shade inside this parabola. So lastly, the direction said, label the solution set A. So where they overlap, I'm going to stick an A in there. And then state one point that lies in the solution. So pick an obvious point. I'm going to say if I go over 1 and up 1, 2, 3, that is very obviously in the solution. So I'm going to go with 1, 3. And there you go. We've graphed a system of inequalities. All right, exercise 3. Take a look at this bear. They've written it a little oddly. So watch how we rewrite it. I can say x squared minus 4 is less than y. Okay, so I'm kind of ignoring this half of it. And I can say y is less than or equal to 5. Do you see how I have two systems in there? They wrote it as one, but there's really two. Let me say it again. This piece is less than y, and y is less than this piece. All right, so again, I'm going to do it in two separate colors. Y is by itself, so let's go ahead and graph the x squared minus 4. Put it in your calculator, plot some points. So hopefully your points look the same, and I just have to determine whether it's solid or dashed. And as I box this symbol in, hopefully you're saying in your head, dashed. So I'll connect them with a dashed line. And remember, we're just going to put arrows on the end, implying that this graph goes up forever. And lastly, I just need to test a point. So remember, you can pick anybody that is just not on this line. And again, I'm going to go 0, 0. That's an easy point for me to do my math on. So I'm going to test 0, 0. 0 squared minus 4 is less than 0. So I said negative 4 is less than 0. Is that true or false? Is negative 4 less than or smaller than 0? Hopefully you're saying that is true. So I'm going to shade where I saw 0, 0. Okay. Second graph, y is less than or equal to 5. So basically I'm graphing y equals 5. So 1, 2, 3, 4, 5. I'm going to the y-axis, and I've got my y value of 5. And is it going to be dashed or solid? Well, again, that line underneath tells me a nice solid line at y equals 5. Again, arrows on the end. Now, I have to test a point. So let's say I pick the point 0, 0. Is there any place to plug an x value in? No. So I'm just saying 0 is less than or equal to 5. Would you agree with that? I hope so. So that means I'm going to shade below this line. And again, notice my shadings just go across the whole page. And lastly, I'm just going to put an S for my solution set, and that is where these two graphs overlap each other. Alright, let's switch gears and try a multiple choice question. Now, you can usually narrow these questions down by 50% just by looking at the dashed or solid. Because we see a dashed line, do we want to see the equal sign underneath or not the equal sign? Hopefully you might know by now we don't want to see the equal sign. Okay, so now I just have to determine a point to test and see which one's true. Again, I just love this point 0, 0 if I can use it. So I'm going to test it in the first one. I'm going to say 0 is less than 0 squared minus 3. So I basically get 0 is less than negative 3. True or false? Is 0 smaller than negative 3? Hopefully you're saying false. And if you can't think of it, picture a number line. Is 0 smaller than negative 3? No, negative 3 is to the left of it. And just to be clear, I'll try this one just to prove to you. If I plug in 0, I get 0 is greater than 0 squared minus 3. Is 0 greater than negative 3? I would say that's true. So I'm going to go with choice 3. Alright, well, last question of the night, exercise 5. An arch bridge crosses a 600-foot span above a river. Its structure, as viewed from the side, occupies the two-dimensional space given at that set of inequalities shown below. Produce a sketch showing the side view of the bridge. Label all relevant features of the graph. Alright, so we're really going to talk about using our calculator at this point. First thing I want you to notice is this section here. This is called our domain, which you should be familiar with. Remember, the domain is the set of all x values. So they're telling me I have to graph from 0 to 600. Okay, notice the x in the middle. That's how I know it's domain. Notice that they don't give us a range at all, so we'll have to keep that in mind. Alright, now, this is that goofy equation, and it's split, so we can write two equations. The first one is this fraction is less than or equal to y. So 600x minus x squared over 360 is less than or equal to y. And my second equation, I'm just going to pick it up here, is y is less than or equal to 300. Okay, so there are my two equations that I'm going to graph. Now, let's talk some calculator tips. If you have that updated calculator that we talked about, here's how you're typing this in your y equals. If you hit alpha, y equals, you will see that n over d for numerator denominator. If you have that ability on your calculator, basically of that TI-84 plus, you are hitting alpha and the y equals button, and you'll see that. And then a fraction will appear, and you can type in the 600x minus x squared over 360. If you don't have that, if you have the old TI-83 calculator, okay, you don't get this cool fraction button, you have to be very careful. You have to wrap the top in parentheses, 600x minus x squared, divided by bottom in parentheses, 360. Either way, we're all typing that in our calculator, so pause it and figure out which one you're going to use. All right, now here comes the fun part. Now that we have that in y equals, we can go ahead and hit, and these are things you'll probably want to write down, zoom 6. Recall, that's going to get us our standard window, and that's kind of that 10 by 10 window. Here's what my calculator looks like. Now, you'll notice I should know what shape this is going to make. Because there's an x squared in the equation, I know I want to see a parabola, okay? And because it's a negative in front, that parabola should be facing downward. Now, I can't see the parabola. Clearly, I can see this side of it here because this is going up, but I need to see more of it. And here's where it gets exciting. You're going to have to pay close attention to the details. We need to change our window. Okay, so you all have a window button. It is right here. You are going to hit that window button. Again, here's a picture of my screen. When you hit that window button, what Zoom 6 does is set everybody to 10s. Negative 10, positive 10, negative 10, positive 10. X min is my X min this way. X max is my X max this way. Y min would be down here. Y max would be up here. So again, Zoom standard or Zoom 6 sets it everybody to 10s. Now, we were given a domain. If you look back in your notes, the domain they said was from 0 to 600. And what that tells me is my X min and my X max. Please make sure you're jotting these down as well. This isn't something I'm saying for, fun. Make sure you have this in your notebook. X min, X max. All right, so we're going to change the X min to 0. That was our min. And we're going to change our X max to 600. Now, I'm not going to change anything else at the moment. I am going to hit the graph button, which is in this upper right-hand corner. If you just hit graph, it might take a few seconds, and you will get this screen. Notice I went from 0 to 600, so I don't have any negative x values, and I'm still at a 10 by 10. Now, you should see just a tiny little piece of your graph. As you can see, I can kind of see it going up here, and I can kind of see it coming down here. Now remember, we said it's a parabola, so we know the graph looks something like this. I just need to see more of it. So here's what you have to say to yourself. I need to see more upward. Because I'm going up, that is the y-axis, and because I'm going up, that makes it a max. So I need to go back to my window button and play with this y-max. 10 was too small. Maybe I'll try 100. So what I did is I changed my y-max to 100. I didn't touch those, and again, I'm going to hit graph. Might take a few seconds, but this is what it showed me. And look, we're getting there. We can see more of the parabola. Okay, so now I'm going to use some common sense. Remember back in the beginning we wrote those two equations? Let me scroll back here. I know the y values have to be smaller than 300. So what I'm going to do is I'm going to use some common sense, and if I know my y values are smaller than 300, I'm going to say, okay, I'm going to make my y max maybe 350, just so I can see my picture perfectly. So go ahead and change that window and hit graph again. And this time you can see a much better picture. You can now see this entire parabola. Okay, we can see that whole thing. Now, I want you to go back to your y equals, and in y2, we're going to graph that line 300. That was my second equation. Okay, so go ahead, hit your y2, hit your 300, and hit graph again. And when you do that, you will see both the lines that I have in my picture. Okay, can you kind of see the bridge developing? And that's what that question was about, remember. We want to see this bridge. So let me recall my two equations. I need to quickly sketch both of those over the correct domain. So what I'm looking for on paper is a nice first quadrant. We know we started at 0. We need to end up at 600. Okay, so I'm just looking for a sketch on paper. I'm going to graph this function here in black. And just take note, am I going to use an open or, a solid or dashed line? So I know it looks like this, and it's a nice solid line. Okay. And then I'm going to graph that line 300 in a different color. And if you looked at your calculator screen, you could clearly see that that line was above the parabola. I'm going to graph that line. Okay. And now I just want to shade in the appropriate spot. It said this graph is less than or equal to y. Now, I'm just going to test a point before I shade. Remember, I can't pick 0, 0 this time because that is a point on the graph. So I'm going to pick the point right here. 0, let's say that point is 50. Okay, 0, 50, because remember, this graph is at 300, so 0, 50 is a fair guess. So if I plug that in, I'm going to get 600 times 0 minus 0 squared over 360 is less than or equal to y. Whoops, is less than or equal to 50. Is 0 less than or equal to 50? That's true. So this is the section I'm going to shade in. Okay, above the parabola. Let me test that same point, 0, 50, in this equation. Okay, I'm plugging 50 into y, there is no x. Is 50 less than or equal to 300? Yes, so again, I'm shading underneath for that one. So you can see that I'm shading in the same section. And hopefully, the question said, after all this, to draw the side view of the bridge. And I hope you can see where we can use these parabolas and lines to get some real architecture in here. Well, that does it for us. I know that was a lot of buttons to press, but hopefully you took your time and you'll be confident tomorrow. Have a great night.